a brief overview of the technology behind the web and the internet in general. This won't go into a ton of detail, but I think it's important to get a feel for how these things work and where they came from. So we start out with defining some terms here. We want to define what's the difference between the internet and the web. These terms are often used interchangeably, but they really are separate things. See, the web is just one of many applications that runs on the internet. Other internet applications might be things like email, SFTP for transferring files, instant messaging, multiplayer games, Skype, and so on. A lot of these programs also have a web-based version, and it's very common for a lot of applications to move in the direction of being web-based. But there's a lot of other aspects to the internet, so the web is just one part of that. So what's a network? Well, we start with a local network, a local area network. Now, this is, a network that would be within your house or within a company or something like that. It's the computers all within one, relatively small physical space that are connected together. And before the internet, we had networks that you could connect to that were larger area networks, things like CompuServe and AOL, Prodigy, and bulletin board systems and so forth. And this allowed you to connect your computer to a network that maybe was spread over a larger geographical area. And so this is called internetworking, where you can connect maybe your local network in with another network at a different location to create yet a bigger network. The internet is the ultimate in internetworking, and so that's where that term actually comes from. And so this is a representation sort of what the internet looks like in terms of connections of all these different networks. So each of these little starburst things would be, an individual network at a company or university or whatever. And then they're all interconnected so that you can get from any one point on the internet to any other point on the internet. And everything has a unique address and a unique path to it, and oftentimes multiple paths. And that's one of the reasons why networks are so resilient. Here's another representation of long distance connections. So showing how you can have connections throughout the entire globe between different countries. One of the things that was an early aspect of the internet was the idea that we would make a communication network that was capable of having large areas of it destroyed with, a nuclear war or something like that. You'd still be able to have communication. The internet actually came in some part from military research. And so that's one of the things that's made it so resilient to, just all the things that happen, to physical devices in the real world. And that's one of the reasons why the internet is so resilient to problems. Here's an example from our campus here at UNI. This is the server room that I have a whole bunch of equipment in that I take care of for my day job at UNI. And this is actually a network rack, and it shows some switches and routers and patch panels and so forth, and all those little blue cables and green cables and yellow cables. Those are Ethernet cables. It's what transfers data from one machine to another on campus. This next picture, it's another picture from our server room. It's actually on the opposite of the aisle from the previous one. These are cabinets with computers in them, big servers, including some of the servers that handle the UNI web cluster that you're actually going to get some experience on here in the coming weeks. So if we have the web now, did it come into existence all on its own, or was there something that came before it? Well, actually, there were quite a few things that came before it. The web is a hypertext network, which means that you have multiple documents that can be linked together, and the end user can then make connections between pieces of information by following those links. Now, the first example of this is from the work of a guy named Vannevar Bush. He developed something called the MEMEX, and he described this in an article in the Atlantic Monthly called As We May Think, which was a futuristic kind of proto-hypertext vision of the internet before most of the technology was even existent to implement any of that. He did this in 1945, shortly, right towards the end of World War II. It was really amazing that he was able to, develop these ideas so early, even before the information processing technology was there. And so it was never really implemented. And then you fast forward about, another 20 years or so, and we have Project Xanadu, which was developed by a guy named Ted Nelson. And this was the first actually implemented system for doing this kind of hypertext networking and clicking on links and things like that we would, recognize as something that's sort of web-like. And the web itself had to wait, basically another 20 years before the technology was really there for it to happen. And this was done by a guy named Tim Berners-Lee, now Sir Tim Berners-Lee. He's been knighted for his work. He was working at a place called CERN, which is a European physics laboratory. And he developed this system where we would have servers and browsers and have a protocol for them to talk so that information can be transferred between different machines. And he developed this with, relatively inexpensive computers that were widely available by that time. And the original intent was for scientists to be able to share information on the internet. The internet existed, but we didn't have the web, if you can imagine that. And so transferring files around usually meant emailing them or transferring them with FTP or something like that. And this was the first way that you could bring them all together and show connections between all that information. So what are these different parts that Sir Tim Berners-Lee put together? The first part is the web server. This is what stores and serves web pages. And so these are just computers. They can be, something as simple as a $35 Raspberry Pi computer that you can buy, all the way up to, multi-million-dollar machines. But in the end, it's just a computer that has files on it that can answer to requests and serve those out. So this can be static content like HTML or images. It can also be dynamic, so it's program generated, things like WordPress or My Universe on UNI or Facebook or something like that. So if you got a server, you need to be able to talk to that server, right? And so you need to have a language to speak. And so that's what the web protocol is. And the main protocol for the web is HTTP, the Hypertext Transfer Protocol. This is just plain text. It's easy to read once you learn the language, and it's fairly lightweight from an information standpoint. So it's really easy to transfer information back and forth. The problem is it's plain text. So anybody that can intercept that connection, that communication, can see what's being said. And so there's HTTPS, which is a Hypertext Transfer Protocol secured, that uses encryption to protect that communication back and forth between the server and your browser. This means there's a little bit more overhead because there's fancy math that has to happen for the encryption. But if you're talking to your bank or something like that where you want to protect that communication, you want to be able to use encryption to do so. And finally, over that communication channel, you have to have a language for describing how things are going to be displayed on the screen. And that's where HTML comes in. It's the Hypertext Markup Language. So it tells the browser that this text should be big and this should be red and the image should go over here and so forth. It's the how of how web pages should end up looking on screen. And finally, in order for them to look on, to display on screen at all, you have to have a web browser. Now, the web browser is what you use to make these requests out to the web server, and also when you get the response back, to be able to display it on your screen. So it's going to speak to the server in HTTP or HTTPS. It's going to render the HTML and images on the screen, and it's going to allow for user interactivity. So you can write emails and post things on Facebook and do all the other things that people do on the internet. And it really, it's quickly becoming the primary way people use computers. Most applications nowadays are web-based in some form or another. But what about apps, you might say? Well, apps are just programs, right? They're just programs that run on a mobile device. And we happen to not think that the word program was fancy enough, and so we started calling them apps, and for short for applications. Apps oftentimes use a connection to the internet to get information. I mean, that's really one of the big deals about having a mobile web connected device. The dirty little secret is that most of that communication is actually web requests, and it's going out to web servers. There's nothing fancy or magical about it. Most of the time an app is just a very restricted little view of the web. And so even when you're using apps on your phone, you're still a part of the web.